Everybody ready? What is always the first reason? Different. Okay, so let's go ahead and set that up. So we're going to write angle A is congruent to angle C. And then we're also going to write that BD is perpendicular to AC. The first thing I need you to do is mark the two angles that it tells you are congruent.
Right, circle it.
Yeah, in your picture, like put the little curves for the two angles that they tell you are congruent. What two angles does it say are congruent? A and C. So in your picture, well, it's like a little curve. Like, see how I'm doing right there? A and C. Okay, that means those are congruent, correct?
Yep.
Okay. So you got to start thinking about what they tell us and if that leads us to say anything else. If I have congruent angles or I have congruent segments, there's not a whole lot I can say after that. So anytime you give me some congruent angles or some congruent segments, I can't talk. Mark them in the picture, but that's not going to lead us to our next statement, okay? But what else did they tell us? What does that upside down T mean? The other one, perpendicular. So that says that segment BD is perpendicular to AC. Okay, so that line in the middle, BD, is perpendicular to the line at the bottom, AC. What kind of angles do perpendicular lines form? What type of angle do perpendicular lines form? Well, together, yes, they would form two angles that make 180, but what would each of them be if it's straight down? 90. So anytime they give me some perpendicular lines, I can always name some right angles. And if BD is perpendicular to AC, that means this angle right here. Do you see where I just put the little box? How would I name that angle?
90.
Well, yes, it is 90, but like with letters, how would I call it? What would its name be? BDC. So what we're going to do is we're going to say angle BDC. And if that side is a right angle, what is the other side?
It's got to be a right angle.
It is also a right angle. And how would I name this side? Well, first, before we say they're 90, we have to say that they are right angles. Now, how do I know that they are right angles? What was I told in the given statement that said, okay, those things make right angles? What kind of lines? Perpendicular. So the reason is going to be the definition of perpendicular, and I'm just going to use that abbreviation there, okay, because I don't want to write the big long word perpendicular. Is everybody okay so far? Okay. Now, I know that those two angles are right angles, which means they both equal how much? 90 degrees. Well, if BDC and BDA are both equal to 90, can we say that those two are congruent? Okay. So that's what we're going to say next. We're going to say angle BDC is congruent to angle BDA. And there was a theorem or a corollary we talked about a while back that we might not quite remember, but it says that all right angles are congruent. So that's what we're going to put here. All right angles are congruent. So I started with the fact that A and C were congruent. We marked that in our picture. That doesn't lead me to say anything else. But the other part of my given said that BD is perpendicular to AC, which forms our right angle. So that's what we were able to say in that second step, right? And then because we know that they're both right angles, we're able to say they're congruent because all right angles are congruent.
When did the 9 say?
At the break, at the Christmas break,
Oh, Christmas, not Thanksgiving?
not Thanksgiving.
Oh, damn.
No, your progress reports go out this afternoon, actually. So halfway through. All right. Now that I have some angles congruent, that is not going to lead me to say anything else. Okay, congruent angles and congruent segments don't lead me to another step. Do I have any other given information that I can use? No. Okay. So looking at my markings in my picture, do I have enough for side, side angle, or angle, side yet? Do I have any sides marked congruent yet? No. So what we're going to have to do, because we don't have any other given information, is we have to look at our picture. Do we see a pair of segments that are congruent? Which one?
AB and BC.
Okay, they look like they're the same, but I don't know that they are because I haven't been given any information about that. But how many? You have two triangles up there, right? What about that?
C, B, and D. I mean, D, B, C.
AB, BC.
Don't know that yet either because they didn't tell me D was in the middle. It looks like it, but I can't assume that. Well, what's the side that they share?
BD.
BD. Isn't that the same side in both triangles? So it would be congruent to itself, which we can say. What says we can say something's congruent to itself? What property? Mm-hmm. Do I have enough now to say my triangles are congruent? How many pairs of angles do I have marked congruent? Two, technically. We have the two A and C, and then you have the two right angles. And then I have one side, yes? So yesterday we learned about two different options with two angles and one side. It's either angle, side, angle, where my side is in between my two congruent angles, or it is angle, angle, side. So in this picture, the segment that is marked congruent, is it directly in between my congruent angles? Okay, let's look at here. Here are my congruent angles in this left. Is my side that one that I highlighted? No, it's not.
No.
Okay. So if you look at this, it is angle, angle, side here. So do I have enough now to say my triangles are congruent? All right, so I'm going to copy down my prove statement. It says to prove that triangle ABD is congruent to triangle CBD. And what did we just say that was? Angle, angle, side, yeah. And I just want to show you the difference between the two. And when we do this, we really focus on just one triangle. Angle, side, angle would look something like that. Whereas angle, angle, side would be, do you see the difference between the two? Angle, side, angle versus angle, angle, side. Do you see the difference of where the markings are there? So that's kind of how you tell the difference. Is everybody good with that proof? All right. This one is a little bit different given information, but also the same picture. So take a minute, recopy it, write your given information, what we're trying to prove. A lot of these proofs you will notice have some of the same steps over and over and over again. And once you get used to what you're given and where it takes you, then that may help. No, I'm just writing like a little cheat sheet down.
Can you write it down?
So this is kind of like a cheat sheet, sort of, for your proofs. And it tells you if what information you're given and what that will lead you to say, like, can you get another statement from that? So if I'm given either congruent angles or congruent segments, there's nothing further I can say about those other than marking them in my picture. If I'm told something is the midpoint, then I could say for my next statement in my proof that I have some congruent segments. I would just name which ones were congruent, and that would be the definition of midpoint. If I'm told that I have an angle bisector, then I should be able to name some congruent angles, okay? If I'm told I have what's supposed to be segment bisector, if I have a segment bisector, then I should be able to name some congruent segments. And if I have some perpendicular lines, I should be able to name some right angles, which would then allow me to say that.
That's like a cheat sheet.
Kind of. People always ask, how do you know what statement to say next? It's based off of the information that I'm giving and what that allows me to say after that. So that's kind of a cheat sheet for if you're given this information, what can you say? Does that make a little bit of sense? Okay. All right, so let's go ahead and set this thing up. As always, the very first statement and the very first reason is you're given. Now, what does the very first part of our given information say? BD does what? Bisects angle ABC. So if I'm told I have an angle bisector, my next statement should be able to name what angles are congruent. Okay, so let's look at our picture. If BD, this red line right here, bisects angle ABC, what would be the two small angles that are going to be congruent? Yep. Okay, so what we're going to do next is we're going to say, if I could stop hitting that button, we're going to say that angle ABD is congruent to angle DBC, and I'm going to mark those in my picture. Okay, so do you see how I have my congruent markings in my picture for angle ABD and angle DBC? The order of the letters, like you could call it DBA and CBD, as long as B is in the middle of both of those. Now, how did I know those were congruent? Because they told me I had a what? Angle bisector. So the reason for that is going to be the definition of angle bisector. And you'll notice I'm abbreviating. I'm just putting the symbol there for angle because I don't want to write the word. So statement 2 has some congruent angles. Does that lead me to say anything else? Does congruent angles lead me to say anything else? What other piece of information was I given? I was given some perpendicular lines. So if I'm given perpendicular lines, what should I be able to name next? Right angles. So let's tell what angles are right angles if BD is perpendicular to AC. How would I call this one that I'm marking with the box? What's its name? A what? And what other angle is going to be a right angle? How would I name the other side? CDB? And how did I know those were right angles? Because it told me that the lines were perpendicular. So the reason is going to be the definition of perpendicular. Oh, I didn't finish my statement. Yes. Now, if I'm saying that I have two right angles, what should I be able to say next? That those two right angles are congruent. So I'm going to use the same names. Angle ADB is congruent to angle CDB. And that's because all right angles are congruent. Okay, all right angles are congruent. So anytime you're given perpendicular lines, that should lead to two more statements. Saying which angles are right angles, and then saying that those two right angles are congruent. Do I have enough marked in my picture yet for angle, angle side, or angle side angle? I don't, do I? I just have two angles marked congruent, right? I don't have any segments marked congruent. Do I have any more given information to use? No. So then we have to go to our picture. What is it that we see in our picture that we can say is congruent? Yes. BD is the shared side, so it is congruent to itself. And what's that reason? Mm-hmm. Do I have enough now to say that my triangles are congruent? Yes. Which way? Angle, side, angle, or angle, angle, side? Angle, side, angle. So for my last statement, I'm going to write my proof. What is it? ABD and CBD. So triangle ABD is congruent to triangle CBD because of angle, side, angle. And I just want to point out and make sure you guys understand this last statement that I write, I'm not coming up with it. That's what I'm trying to prove. I always just recopy that for my last statement. It's not something that I make up. It's what they told me I needed to prove. The only thing I have to figure out is what's the reason for it. Kind of okay there? All right, let's do this one. Oh, I forgot. I got to add another thing. Copy that one down. I got to add one more. Right. Yes. Yes. Those little symbols, they're hard to see in between A, B, and ED. That's parallel. I'll darken it in a little bit. Parallel right there. So I added another help for our cheat sheet. Parallel lines usually allows us to say some congruent angles because we have like alternate interior angles is what we use mostly on these proofs. So let's go ahead and set up the very first statement and reason like always. Everybody ready? Not yet? Okay. While we're waiting on people to catch up, what I want you to do is look at that first bit of given information. It says C is the midpoint of what? AD? So look at your little cheat sheet. If you're given a midpoint, what should you be able to tell me? Look up on the board. If you're given a midpoint, you should be able to say congruent segments. So what I need you to do is tell me which two segments are congruent if C is the midpoint of AD. Okay, look at your segment AD. I'm going to highlight it so we can see it a little bit better. If C is the midpoint of that, what two segments should be congruent? So we're going to say segment AC is congruent to segment CD. We're going to mark that in our picture. And how do I know they're congruent? Because it told me that C was the midpoint. So that's going to be the definition of midpoint. It's not here.
I already tasted.
Okay. Oh, I forgot. She did. I think she sent an email. She'll be back next period, if I'm not mistaken. So far, so good? Anybody have any questions? All right, so I used the fact that C was the midpoint of AD, and I named some congruent segments. Those congruent segments do not lead me to say anything else, right? Congruent segments don't lead me to say anything. What's the next piece of my given information? All right, so let's take a look. If AB is parallel to ED, I should be able to name some congruent angles from alternate interior angles, and you can do this a couple of different ways. This proof could actually be done several different ways. Let's look at this AD as my transversal. What would be my alternate interior angles if I'm looking at AB at the top and the bottom and then the green one? What two letters would be congruent as alternate interior angles? Okay, in between the two yellow lines on opposite sides of the green. A and D, yes. I would be able to say that angle A is congruent to angle D. Let me erase my highlighting so that you can see. Do you see where I put the blue markings in my angles? Do you see that those are alternate interior angles? Okay. So what we want to do is we want to say that. We want to say that angle A is congruent to angle D. Do I have another pair of alternate interior angles that I could say are congruent here? I could also say that E is congruent to B. So I'm going to write that as well. And the reason is that alternate interior angles are congruent. Do I have enough marked in my triangle to say that these two triangles are congruent? I do. By what reason? Angle, angle, side, yes. That is angle, angle, side, and I will highlight angle, angle, side. Okay, the side is not in between the two congruent angles, so therefore it is angle, angle, side. Oops, I erased my letter. Ugh. Try that one more time. if you use this, it helps you figure out what can I say next. Everybody ready? I got one more. I want you to try this one. Okay, using the little cheat sheet I have up on the board. Keeping in mind that today we're just practicing proving these triangles congruent by angle, angle, side, and angle, side, angle. Set this one up. Mark what it says is congruent. Use what it gives you. Use the cheat sheet on the board if you need to say, what can I say if I'm given this information? Keep in mind how important it is to have your picture drawn so that you can put your markings on it, so you can see how you're proving the triangle's congruent. If you don't mark your picture, you're never going to be able to see what you have. With the first piece of your given information, mark it in your picture. Does that tell you anything else? If not, move on to the second part of your information. If you're given congruent angles, does that allow you to say anything else? No. What's the other piece of information they give you? They give you a what? Midpoint. So you should be able to name some congruent segments. Mm-hmm. What two angles does it tell me are congruent? B and E?
Hey, go to the bathroom real quick.
No. All right. Does knowing that I have congruent angles lead me to say anything else?
Nope.
No. What other piece of information does it give me? It gives me a midpoint, so I should be able to name what segments are congruent. If C is the midpoint of BE, what two segments would be congruent? Yep, EC is congruent to CB or any combination of those letters. I'm going to mark that in my picture. And that is the definition of what? What did they say C was? The midpoint. Now, knowing that I have congruent segments, does that allow me to say anything else? Do I have any more given information? I don't, do I? Right, I've used both pieces that they gave me. So when we have used all of our given information and we still don't have enough to prove our triangles congruent, there's going to be one of two options. You're either going to have a side that is shared. Do I have a side that is shared in these two triangles? No. Or you're going to have a pair of vertical angles. Do I have a pair of vertical angles in this picture? Yes. And we all know that vertical angles are congruent. So can we just, by looking at this picture, tell that ACB, that angle right there, is congruent to its vertical counterpart, which is angle ECD? And that is simply because vertical angles are congruent. Now looking at your markings, do you have enough to say your triangles are congruent this time? Okay, how? I'm hearing two different things. So I want you to, when we do this, let's focus on one of our triangles. I'm going to cover this one up just for a minute. I'll uncover it so you can finish up drawing it. So if I'm looking at this, and when I say we want to focus on one, it's easier to just look at one triangle and determine, is it angle, side, angle, or angle, angle, side? Where is my side? Is it in between my two congruent angles in that triangle? It is. So this one would be angle, side, angle. If it weren't in between, it would have to be like this one up at the top or this one over to the side. Okay, but because it's the one that's in between, then we can call it angle, side, angle.